So, hello everybody. So today we're going to discuss about Thevenin and Norton equivalent circuits. During this tutorial, feel free to ask any kind of questions regarding the problems or the theorems that we are using, equations or anything relevant throughout. You can use our chat or just turn on your microphone. Anyway, feel free to ask the questions. So first of all, let's talk about what is exactly Thevenin and Norton equivalent circuits. So in a circuits world, we have some kind of sources that is giving us resistance and some kind of a voltage or current, and the load. So in order to minimize the loss, we will explore two new terms called Thevenin theorem and Norton theorem. This kind of a PDF files will be shared after this video. Now you can read full, but I will make it short. So according to Thevenin theorem, all of the sources will be equivalent to some kind of a Thevenin voltage source, this independent source, and Thevenin resistance, as you saw here. And according to Norton theorem, there is just one difference between these two theorems. Instead of voltage source, we will use current source, and instead of connecting our Thevenin resistance in series, we connect it in parallel. So basically, the differences are just here, not in series, but in parallel, not in current source, but a voltage source. So how to do it? So how to determine the Norton or Thevenin equivalent resistance? First of all, we will assume all of the voltage source is just a wire, just a straight wire, and about independent current sources like this independent current source, we will assume they do not exist. Just we will leave them that they just don't exist in our circuit. So and just use simple and basic laws of physics to determine the total resistance. So how to compute Thevenin voltage? For example, we have two terminals here, or just 2 points, and we want to find the Thevenin equivalence between these 2 points. How we will do it? So first of all, we will just assume there is no exist load, and we will create some kind of this kind of open circuit like this. So VOC stands for voltage between open current circuit. Sorry. And just use method mesh current or node voltage to find out VOC. Basically, the Thevenin voltage will be equal to VOC. So these are other samples. You can just show them. So let's go directly to the questions, examples. So what about this circuit? So we have one independent voltage source and one independent current source. And we have A and B points. So let me take this one. So basically, in order to find the resistance, the Thevenin resistance of this circuit, as I said, we should assume this V just a straight wire, and about independent current sources, we just assume they never exist in a circuit. So let me just cross this out, and instead of V, we will just use straight wire. So assume there is no any kind of voltage source here. This is just a straight wire. So what we will get, R1 and R2 will be connected in parallel, and others will stay like this. So basically, in order to find other values, let's see some exact problems with numbers. So hold on, guys, 1 minute. Okay. Sorry about pause. Okay, let's see this sum. So we should find Thevenin equivalence across this 40 ohm resistance. First of all, what we will do, we will cut this load. So let's assume 40 ohm as a load, and other parts is essential us to find out other values. So let me just maximize it to pay more attention to it. So ignore this part. Let's assume we have A and B terminals across it, like plus or minus, yeah. And between them, there is some kind of a voltage source. We should find this exactly. So let's call it VO. So if it's VO, so what is the potential here? Now we want to use node voltage method to find out the other values here. So as you saw the picture, we take this node as a reference node, which means its potential is equal to 0. Electric potential is equal. What? I can't understand.
Okay. Actually, firstly, let's explain why you've written V0 here, I mean VO, about the 0.6A, because there's no resistance, there's no voltage drop or voltage rise. So that's why we write here V0, okay?
Yeah.
Yeah, let's continue.
Thanks for addition. Of course, to clarify why there is V0, just a V0, because there is no reason. This is just a straight wire, and there is two sources, but actually there is no resistance. That's why it's just straightly VO, like a VO here. So what about this point? So what about this point? So here is independent voltage source, and our VO connected to the positive polarity of the voltage source, which means that in this point we get electric potential like VO minus 24.
Actually, guys, imagine that from V0 position, we are going to the left and we are meeting the voltage source with a polarity plus. And that means plus means voltage down. Okay, so that means we have to subtract from V0 minus 24, and then we will reach the final pass. Okay, so final node. For example, if you go from V0 minus 24 to the right, you will get the polarity minus, I mean, from left to the right, and that means plus voltage rise. So overall, you will add plus 24 and again reach and again get V0, okay? So overall, when you meet the polarity plus, you subtract voltage. When you meet the polarity minus, you add voltage.
Okay, let's create equations then. So what about this point? Actually, we'll deal only about this point. So from the left side, we encounter 10 ohm resistance and 12 volt voltage. So it will be
Actually,
like,
could you please also write directions? I mean, draw directions. I mean,
sorry.
yeah.
I forgot about directions. I just assume in my head. So according to the node voltage law that we have discussed it in a previous CL tutorial, we will assume all of the currents will going out from the node, just outgoing currents. We should assume like this, and
Stop here. Okay, see guys, if there is an independent source between two nodes, that means this is a super node, and you have to consider these two nodes, I mean, simultaneously together. Okay.
We should also take into consideration this guy, 0.6 amperes.
Because between two nodes there is a independent voltage source. Okay, if there is independent voltage source or current, so I mean, in most of the cases, a voltage source. If there's a voltage source, you consider those 2 points together.
So basically, let's label as S. So these two guys are supernode. Shahro just explained about this. So anyway, let's continue about this part. V0 minus 24, which is the electric potential of this point, then minus 12 volt, divided by 10. Divide by 10. And what about this guy? It's just connected to the reference, which means its electric potential is 0. So we should just divide VO minus 24 by...
Actually, we can also remind that we find the current from subtracting the higher potential from lower potential. Current always goes from high potential to low potential. For example, in the example 1, potential high is V0 minus 24, and it goes to 12. So that's why we subtract V0 24 minus 12. And in the second case, the high potential is V0 minus 24. I mean, the current that goes through 40 ohm resistance. And the low potential is 0, as you can see. It goes to the ground. So that's why V0 minus 24 minus 0 is actually V0 minus 24 over 40. So we also consider, as we have said above, this independent current source, because we're considering those two nodes, V0 minus 24 and V0 together.
So
and
why
okay.
You can answer about why we take minus 6.0 here as 0.6, sorry about. Why? Because it's entering, not leaving this node. That's why we should use minus 0.6 here. And now, tadam, we have just one variable here, why one unknown, and just we can use our arithmetics to solve this equation.
And by the way, I'm gonna add that the current doesn't go to the right. I mean, from V0 to the right, because there is an open circuit. Okay, and this V0 is actually Thevenin. I mean VTH. And in order to find the resistance, I mean, across the 40 ohm resistance, we have to do additional operation. This is, I mean, Thevenin voltage. Okay, but initial question was to find the voltage across a 40 ohm resistance. So that's why you have to consider a question like, okay, could you please write, I mean, Shahro, V, I mean, yeah.
So you mean
V?
about the voltage?
Yeah. I mean, we have found right now Thevenin voltage, but in order to find 40 ohm, I mean, voltage across the 40 ohm resistance, we have to do additional operation. Okay, let's write it V equals above V0, and this is V0, it is V Thevenin over RTH, R Thevenin plus RTL, RL, just RL plus RL, and multiply to RL. I mean, so you can ask now, what's RL? RL is our 40 ohm resistance. It's a load. And what's RT? It is equivalent resistance, okay? And you have to find out equivalent resistance. I mean, yeah, Shahruh, you have explained, yeah? You have to kind of redraw the diagram.
Yeah. I just want to do this also in the end of this problem,
Okay.
but you said it beforehand. Of course,
Okay.
in order to find the voltage across this 40 ohms, but at initial I put the question about finding the Thevenin equivalence between these 2 points, these are terminals, maybe you can call. But about the voltage, when it comes to voltage, we should use this formula, just the Thevenin VO, or some kind of open circuit, divided by Thevenin resistance plus loading resistance. So our loading resistance in this case 40 ohms. And what about Thevenin resistance? In the previous example, I've shown how to find the Thevenin resistance. Yeah, assume the voltage sources does just a straight wire, but the current sources doesn't exist. So using this, we will just make some shortages here and find out the values of Thevenin resistance as 8 ohms. Why? Because if we assume this 12 volts and 12 volts and this guys doesn't exist, we just have 10 ohm resistance here and 40 ohm resistance here, and they are connected in parallel. Yeah, so let me draw like this. We will have just the two. Sorry, I have already drawn it here. Here.
Yeah. Okay.
You just give speed to me, Shahrukh.
Yeah.
So this 10 ohms and 40 ohms, as a result, our Thevenin resistance will be equal to 8 ohms.
Okay.
So
Let's
using this
calculate.
formula, it's easy to identify the V, which is equal to, use your arithmetics to identify them. Just put, instead of RL 40, instead of V0, just put 38.4 ohms, and about Thevenin resistance, it's just the 8 ohm, and calculate, and you got the answer 32 volts. If everything is understandable here, so let's move to the next. So we should find this V0 here, I mean in this equation. So let's use Thevenin equivalent in order to identify this V0 point.
So actually, as you can see, in order to find the voltage across any resistance, firstly, we substitute this resistance with open circuit, yeah?
Yeah.
And then we find out this voltage, I mean, open circuit voltage, and come back and calculate V as a formula, with a formula that we have showed above.
In this
So
case, our loading resistance is 800.
Yeah.
So what do you want to say?
Yeah, continue. That's okay. Let's calculate
So,
V0.
So let's continue then. If this is equals to V0, and if this is equals to 50 volts, so we should identify, first of all, sorry, our reference. So let's make this as a reference. Then electric potential here is just a 0. So if it is 0, and if this is a 50 volts, so in this point we should have 50 volt electric potential. And if this is a 50 volts, and if you can see here, if we go like this, in this point we got what electric potential? We
I mean, actually, guys, see, there is the last side. There's a, I mean, 50 volts. Yeah, I mean, if you go up, you meet plus polarity and V0. Okay, so actually, it's going to be this is going to be you have actually it's going to be minus and plus. Shahrukh. Firstly, it's minus and then plus, because yeah. And then see, series of minus plus, and it's going to be V0 plus 50. See, what I'm going to explain you guys, that there's a 50 voltage, and it goes to the up, and it meets, I mean, V0 potential voltage with polarity minus. So as I've explained it a little bit earlier, when you meet minus sign, you add voltage. It's voltage rise. So 50 plus V0, it's going to be at the end 50 plus V0, okay? So there's no reason to write another variable V1 or V2 or Vx just to minimize, to minimize the number of variables. Just use this trick. Be more attention. I mean, pay more attention to this kind of small stuff.
So as you saw here, we will just deal with this node and this essential node. So let's write the equations then. So about this V. So from the left side, we got what? 50 volts electric potential here, and we so
Shahrukh, again, could you please draw the direction of
Sorry.
current.
So let's assume, as the definition, we just assume all of the currents are leaving the node like this. Yeah, I mean
Okay.
only this essential point. We're gonna talk about this later. So we minus 50 volts divided by 80 ohms.
Yes, this was the left current, and now
About the
current is a bit
button, so it's a plus. We
V,
over
and
just a zero
it's going.
because it's a reference. It's
Yeah,
connected to reference. Just a 50 here. Then about the right, it's so about the right, we should V minus V0 plus 50, yeah?
yeah. I mean, the high potential is V, and it's going across 50 ohm resistance to low potential, which is V0 plus 50. So be careful with the sign. Put always brackets. Okay.
Divided
Over
by 40, yes. And
yeah.
all of this stuff is equal to 0.
So now, as you can see, there is one equation, but there are two unknown variables. That means we have to find out one more equation in order to kind of find both variables, V and V0.
So let's write second
So
equation
could
here.
you please, I mean, show the picture, or, I mean, diagram. I mean, yeah.
Okay,
I'm
right
gonna
now.
explain one thing. Yeah, I'm gonna explain one thing. So here, guys, as you can see, there are two additional nodes to consider. The left part 50 ohm, 50 volts, and right part V0 plus 50. As you can see in the left part, in the left branch, there is no resistance, so current doesn't flow there. So that's why please be careful. Do not consider the leftmost branch because there is no resistance. As you can see in the right side, there is, I mean, in the rightmost branch, there is 200 ohm, and that means current will flow there. So that's why please consider this node in order to find out one more equation. When there is no resistance in the branch, that means no current flows there, and there's no point of considering this branch in order to find out equation. Okay. So in this case, after, I mean, if you kind of understood my opinion, my saying, now we'll consider the node where the voltage or potential is V0 plus 50. So here, as you can see, in this node, current will flow to the right
So
through
let
the.
me explain, guy, come on. So about the left side, so let's just write the equation. You are too talk to today. So V0 plus 50 minus V. It's not so complicated. You are making it so complicated. Come on.
It's the current going to the
40.
left.
Yeah, it's a current going to the left and current going to the right. There is just 200 ohm here. So just plus V0 plus 50 over 200. Then what about bottom? So as you saw, there is no resistance here, but we should assume the current should going out from the node, but it's entering the node. It has already given. That's why we should use the minus sign because it's entering, not the leaving. But according to the definition of the node voltage low, it should leave the node, but it's entering. That's why we should use the minus sign, 0.75 amperes.
And can I add something, Shahrukh?
Yes, you can. Why not?
Okay, as you can see here, there is also kind of a way to the up, but no current will flow to the up because there is open circuit. Please remember that in the open circuit, current is always 0. So no current will flow to the up. So that's why we don't consider this way, this path.
Yeah, because
So yeah, that's it.
because it's up and okay. Then what? Calculate this in order to find the values of V0 and V, and you got the values. of V0, which is asked from us initially to identify. Yeah, is anything you want to add?
Actually, Shahruh, again, okay, V0 is not the V0 that's asked, okay? V0 is a Thevenin, okay? Could you please, rewrite it? V0 is not the voltage that's asked. V0 is Thevenin voltage. In order to find V0, we have the special formula. We
Yeah.
have to, the formula that showed above. Thevenin is V0. And let's say we are asked not V0, okay, let's say Vx. Would you please go up and redraw, upper, and it's not V0, Vx, okay, let's say.
Yeah, at the first
So
example.
yeah, do not confuse. V0 is Thevenin. Firstly, we find Thevenin, we have found, and let's find here now Vx.
So hold on just a minute. So guys, any other questions up to this point? If you have a question, please ask.
No question, that means everything is understandable, so you can continue.
So I think there is a shortage of time. That's why we should move to the next, because we have shown how to identify this value. You mean this formula, right?
Let's write it, okay? Because let's write it. You're taking everything V0, so that's why it's kind of confusion to everyone.
Okay, now.
Maybe confusion.
Let me copy it. So let me copy it and paste it here.
So V0, it's Thevenin. It's already found, so you can put all values. But we have to find also our Thevenin, yeah, Thevenin resistance.
Yeah. So we have V0, we have RL, but we don't have RT. So what is RT? So using the technique that I told earlier, you should do not assume this part doesn't exist and this is just a straight wire. And now what we will have 80, 40, 50 and 200 ohms. Oh, this also we should do not assume. We should see this picture and find out R by yourself, and we're going to share the full solution earlier because we have just 10 minutes to close this Zoom conference.
Actually, you can okay, Shahrukh, you can also, could you please go about, show. Actually, if when you kind of remove, voltage and current sources, you get 80 ohm parallel with 40 ohm, parallel to 50 ohm, and then you will get the result of it parallel, series with 40 ohm, and finally all this resistance will be in parallel with 200 ohm, okay? So anyway, you can use this trick, this hint when calculating our T. As Shahrukh pointed, later you will be shared with solutions. Let's move to the next problem.
So let's see something different. With this kind of dependent circuits. So we should find the Thevenin between these 2 points. So how we will deal with this guy? So first of all, what is Vt is equal to Vt? So if we take this as a reference, this point as a reference here, so the electric potential here is 0 and here is 0 and here is 0. So in order to get Vt, so all of the electric potentials here will be Vt. So let's assume this is equals to Vt and this is equals to Vt and this is equals to Vt. Why? Because there is no resistance between them. They are just connected using straight wire. So in using the node voltage law, so we should assume all of the currents going out from the node, and this is going out and this is going out, and to the left also we should assume it's going out. So let's write an equation. So the first equation, so 3ix plus with a plus sign, why? Because it has already leaving our node 3ix, then plus, so vt, so this is t. Oh, let me erase this to make a difference. So this is vt. So vt minus 24 volt. Why? Because the polarity is plus here. It's connected to the positive polarity of our voltage source. Vt minus 24 divided by the resistance between them. It is just 2 ohms here. Then what's plus 4 amperes? I mean, to the bottom, current goes to the bottom. It's just 4. Then what about the right side? What do you think? It is just
Sorry, sorry for interrupting. I have a question. Can I?
yeah, yes, you can.
Which homework you are solving now? I'm just already joined in this Zoom.
Actually, this is just it's not a
It's
homework.
homework or
No, it's not a
which
homework.
one?
It's just examples taken from our textbook.
Which one?
You mean number? So
Okay.
Yes,
hold
number.
on.
Hey, actually,
4.19. 4.19.
yeah.
4.9.
Okay.
Thank you.
But it's not. I mean, it's assessment problem. I mean, it's not in problem section. You can find this problem in the lecture notes of Professor Chonkus. Okay, if you're from,
CC department.
yeah.
Yes,
So
thank you.
okay, not at all. So what about the current to the right? It's just a VT or 8. And according to the notation here, it's labeled as IX, which is used to identify this dependent current source. So what is IX is actually? IX, it is just a current between these 2 points. So according to Ohm's law, IX is equal to V Thevenin, which is the electric potential of this point. I mean, the voltage between 2 points. So over 8. So just put VT instead, VT over 8 instead of IX here and get a value of VT, which is roughly equal to what? Which is equal to 16. So use your arithmetic. And so what about IT, which is the current? If we ask it to identify the current in the Norton equivalent, for example, if we assume there is a current going to the right, so let me pick this green color. Oh, sorry. If we assume if there is some kind of a current going to the right, which is equal to IN, it comes here and divide at this point into 3 parts. The first one is going up, going straightforwardly here, and going down. So basically, IN is equal to 3ix according to Kirchhoff's law, yeah, 3ix plus the potential difference between 2 points, Vt minus 24, or just Vt, and plus 4 amperes, Am I right, Shahruh? Hello there. Ix, 3ix, and Vt over 2. Basically, we can take this like this. I almost forgot about this Ix. Instead of having this and this, we can just use the voltage between these 2 points because it's all also combined in this point. So I'm just speeding because we have very short time to finish. Vt over 2 which is this 2 ohm resistance, and VT is our Thevenin voltage. So find here, and you got another formula according to the notes in order to identify the RT, which is the fastest formula. RT is just equal to VT over IN or IT. It doesn't matter, just I mean this I. So it's equal to 1 ohm. So guys, this was the end of this tutorial. Sorry for the misunderstandings. In the future, we are now collaborating with the IoT administration to getting a premium account for the Zoom platform, and I hope to the next tutorials there will not be such kind of a problems with the shortage of time, with the limits of time. But now we should finish this Zoom conference at this point because of the time. I left only 1 minute to make the calculation and end this video tutorial. So if you have any kind of questions, please ask here or write our discussion group. It's open, because if you ask some kind of a question right now, I also don't have the time to explain it. So this stuff and this kind of a problems with its solution will be shared in this video description in YouTube channel. Please check out our YouTube channel also. I put any kind of links which is useful you to learn about Thevenin and Norton equivalents or the circuit and lab course at this video description. Go and subscribe our Telegram and YouTube channel. Thanks for your attendance.
Thank you, Shohrobek, for a wonderful tutorial.
Thank you a lot. Good luck.
Good
See you
luck.
soon in the next tutorial.
Inshallah. Rahmat.
All right.